Welcome to our lesson on normality in chemistry. This concept is crucial for students in classes 11 and 12 as it helps us understand solution concentration in chemical reactions. So what exactly is normality? Normality is a measure of concentration that expresses the number of gram equivalents of solute per liter of solution. Normality is typically represented by the symbol capital N. Normality is particularly useful when we're dealing with reactions involving acids and bases or redox reactions, where the concept of equivalence becomes important. Now, let's understand the formula for normality. Normality is defined as the number of gram equivalents of solute per liter of solution. Mathematically, it's expressed as normality equals the number of gram equivalents divided by the volume of solution in liters, where gram equivalent is the mass of the solute in grams divided by its equivalent weight. And equivalent weight is the molecular weight divided by the number of equivalents per mole, which depends on the type of reaction. Now, let's see how normality relates to another concentration unit you might already be familiar with, molarity. Molarity, symbolized as capital M, is defined as the number of moles of solute per liter of solution. The relationship between normality and molarity is given by normality equals molarity multiplied by the number of equivalents per mole. For instance, in acid-base reactions, the number of equivalents per mole for an acid is its basicity or the number of replaceable hydrogen ions. For a base, it's its acidity or the number of replaceable hydroxide ions. In redox reactions, the number of equivalents per mole is the change in oxidation state multiplied by the number of atoms undergoing that change. Let's solve a few example problems to better understand normality calculations. Example 1. Calculate the normality of a solution containing 4 grams of sodium hydroxide, NaOH, in 500 milliliters of solution. Step 1. Identify what we know. Mass of NaOH equals 4 grams. Volume of solution equals 500 milliliters equals 0.5 liters. Molecular weight of NaOH equals 40 grams per mole, given by 23 for Na plus 16 for O plus 1 for H. Number of equivalents per mole equals 1, as NaOH contains 1 replaceable OH ion. Step 2, calculate the equivalent weight. Equivalent weight equals molecular weight divided by number of equivalents per mole. Equivalent weight equals 40 grams per mole divided by 1 is equal to 40 grams per equivalent. Step 3, calculate the number of gram equivalents. Number of gram equivalents equals mass of solute divided by equivalent weight. Number of gram equivalents equals 4 grams divided by 40 grams per equivalent equals 0.1 equivalent. Step 4, calculate normality. Normality equals number of gram equivalents divided by volume of solution in liters. Normality equals 0.1 equivalents divided by 0.5 liters equals 0.2 N. Example 2. Calculate the normality of a solution containing 4.9 grams of sulfuric acid, H2SO4, in 250 milliliters of solution. Step 1. Identify what we know. Mass of H2SO4 equals 4.9 grams. Volume of solution equals 250 milliliters equals 0.25 liters. Molecular weight of H2SO4 equals 98 grams per mole, 2 for H plus 32 for S plus 64 for O4. Number of equivalents per mole equals 2, as H2SO4 contains 2 replaceable H plus ions. Step 2, calculate the equivalent weight. Equivalent weight equals molecular weight divided by number of equivalents per mole. Equivalent weight equals 98 grams per mole divided by 2 is equal to 49 grams per equivalent. Step 3. Calculate the number of gram equivalents. Number of gram equivalents equals mass of solute divided by equivalent weight. Number of gram equivalents equals 4.9 grams divided by 49 grams per equivalent equals 0.1 equivalent. Step 4. Calculate normality. Normality equals number of gram equivalents divided by volume of solution in liters. Normality equals 0.1 equivalents divided by 0.25 liters equals 0.4. And notice how the normality of H2SO4 is twice its molarity because each mole of H2SO4 provides 2 equivalents of H plus ions. Now, let's look at some key applications of normality. One of the most important applications is in titrations. In a titration, normality helps us determine the equivalence point precisely using the relationship N1 times V1 equals N2 times V2, where N1 and V1 are the normality and volume of the first solution, and N2 and V2 are the normality and volume of the second solution. This relationship holds true at the equivalence point, where the number of equivalents of acid equals the number of equivalents of base. For example, if 25 milliliters of 0.1 normal sodium hydroxide solution completely neutralizes 20 milliliters of an unknown hydrochloric acid solution, we can calculate the normality of the acid. N acid equals N base times V base, divided by V acid. N acid equals 0.1 N times 25 milliliters, divided by 20 milliliters equals 0.125 N. Let's review some quick tricks for normality calculations. Trick 1. If you know the molarity and the number of equivalents per mole, you can quickly calculate normality using N equals M times number of equivalents per mole. Trick 2. To convert between masses, volumes, and normality, use mass of solute equals normality times volume in liters times equivalent weight. Trick 3. For acids and bases, remember, for acids, number of equivalents per mole equals number of replaceable H+ ions. For bases, number of equivalents per mole equals number of replaceable OH ions. For salts of acids and bases, depends on the reaction's context. Trick 4. In redox reactions, remember, number of equivalents per mole equals change in oxidation number times number of atoms changing. In conclusion, normality is a useful concentration unit in chemistry, especially for acid-base reactions and redox reactions. Remember the key points. 1. Normality is the number of gram equivalents per liter of solution. 2. It's related to molarity through the number of equivalents per mole. 3. For acids and bases, equivalents depend on the number of replaceable H+ or OH ions. 4. For redox reactions, equivalents depend on the change in oxidation state. Understanding normality will help you solve a wide variety of problems in analytical chemistry, especially titrations where the equivalence point is determined by the equal number of equivalents between reactants. Thank you for watching.